I have another example, but the evaluation of this example takes rather long, so I have evaluated beforehand. You have the list plot of city data, then I get the coordinates of the city data, and I apply this to all cities of the United States. So here you can see cities of the United States which are in the data source. And we have country data. Country data can be quite usable for people working in finance and in the economy field, because you get history of gross domestic product, you can get inflation, you can get how the gross domestic product is built up. All of this information is available at this point. Let's take a look. If we make a Tate list plot of country data for France, the gross domestic product between 1958 and 2008, so I choose a time frame before the crisis so that it's not too depressing. And we make a joint 2 and we filled the axis. So these are plot options. We will come again to them later in our lectures. So, for example, literacy rates for the continent of Africa. We can access this data through the Wolfram data sources and make plots directly of them. Financial data. Financial data provides access to current and historical information related to stock prices, opening and closing rates, property values, and more. I show you an example. I make a date list plot of financial data for the stock price, the spot price of the American Insurance Group, I think, AIG, from January 1, 2009. So, you see how it is evolving over time. And of course, this is now AIG. AIG for all available dates. Of course, you can make this dynamic, meaning that you can make something like a ticker. If AIG changes the value, then you get within an update interval always the actual value of this. The sources is Yahoo Financial Data with here. So the same is available for chemical data, for weather data, for genome data. You have the slides, you can go through this. I will now skip this kind of data because I do not think that it is that important for the finance industry. And we go to the last point of my 4 points. This is the document-centric workflow. What do I mean with document-centric workflow? There's the notebook interface. Mathematica allows you to compute, develop, and deploy all within one powerful computational document. This is called the notebook. And I will show you afterwards in the interface of Mathematica how we can open, close, save a notebook and do all the things with a notebook we need to do. The very important thing is notebooks are platform independent, meaning whether you make a notebook in Windows, on Macintosh, Linux or Unix environment, the notebook can be opened and worked on within all of these environments. Notebooks can be easily shared or deployed to clients, colleagues, or customers. They can be easily shared, but of course, the customer needs to have Mathematica himself to work with the notebooks. And naturally, notebooks can be customized to match your needs and workflow. The second possibility to deploy is instant interactivity. I will show you here a plot 3D of sine of x times y between 0 and pi and 0 and pi. So this is a static plot. The plot is nice, but there are hundreds or even thousands of systems which will give you the same plot. Okay? But the unique thing, or one of the unique things of Mathematica is here, that you have the manipulate function. And what you can do now is you can make a dynamic plot out of this static plot. So you can vary, in this example, I vary something like the frequency, and what you see is here, if I vary the frequency, I get a lot of this, I get a lot of more maxima and minima in this periodic structure, and with the manipulate. And a whole lecture will be dedicated to the implementation of dynamic, of controls, and of the manipulate, because this is a very unique feature, but it's very important, a very important feature, because this allows you to make a very fast and rapid GUI design and to create apps which you can deploy to your customers, to your colleagues, whatever.